The universe is sustained by invisible networks of interaction. From the quantum structure of matter to the expansion of human knowledge, the transmission of information has defined the evolution of the cosmos and civilization. At this point in history, where quantum computing and artificial intelligence challenge the limits of classical physics, the data transmission infrastructure faces its imminent obsolescence. The CA25-BSR atomic cable is the convergence of nanotechnology, quantum thermodynamics, and synthetic biology applied to materials engineering. An atomic transmission architecture designed to sustain the information systems of the future. Its properties emerge from the structural fusion of aligned carbon nanotubes, CNTs, with hexagonal white graphene coating, HBN, a topology that redefines the paradigms of transmission capacity, thermal dissipation, and energy efficiency in quantum systems and artificial intelligence networks. The efficiency of a transmission system does not lie in its macroscopic scale, but in the alignment of its quantum structures. The transfer of information at the bit level is a classical manifestation of much more fundamental interactions. Electronic and phononic manipulation at the nanometer scale. 1. Nanometric carbon core. Base structure. Aligned carbon nanotube filaments with diameters between 5 to 15 nanometers and lengths of 1 to 10 micrometers. Electronic charge density. Ballistic propagation with scattering coefficients close to the quantum limit, minimizing resistance and maximizing transmission speed. 2. Hexagonal white graphene coating, HBN. Uniform thickness, 1 to 5 nanometers, monolayer white graphene coating. Dielectric properties, electrical insulation with a band gap of approximately 6 eV, preventing electronic collapse in high-density architectures. Thermal dissipation, conductivity of 390 WMK, allowing operations in extreme environments without loss of structural integrity. 3. Encapsulation with ceramic reinforced polymer matrix, protection against mechanical and chemical loads in high computational demand environments. Total cable diameter, 0.5 mm, allowing implementation in quantum infrastructures without modal interference. In the limits of computing and telecommunications, the transmission of information is restricted by thermal dissipations and resistive losses. The CA25-BSR breaks these limitations by operating on the threshold of physical efficiency, with a ratio between power and data transfer that surpasses any previous technology. 1. Transmission capacity. Data rate, 25 Pbps, petabits per second, exceeding the most advanced optical fibers by an order of magnitude. Transmission latency, 0.1 ms per kilometer, with minimal quantum interference and subcritical attenuation. Compatibility with optical and electronic architectures, allowing integration into hybrid infrastructures. 2. Energy consumption and heat dissipation. Consumption per transmission unit, 0.1 Pbps, with a 99.9% reduction compared to optical fiber. Thermodynamic efficiency. Ballistic electronic transfer without Joule resistance-induced heating. Operation in high-load environments. Structural stability in cryogenic and non-cryogenic environments. The CA25-BSR transcends the limitations of classical systems and paves the way towards a universal quantum connectivity infrastructure. Its optimized design not only represents an improvement in telecommunications, but redefines the foundations of advanced computing and distributed artificial intelligence. 1. Quantum computing and AI networks. Interconnection of quantum nodes. Communication between quantum processors without loss of qubit coherence. Reduction of errors in AI algorithms. Latency-free connectivity for training and modeling large-scale neural networks. 2. Global data transmission infrastructure. Implementation in advanced telecommunications networks, optimizing energy efficiency and structural stability. Interplanetary transmission systems. Possibility of being the basis of quantum communication for space missions. The development of a civilization depends on its capacity to manage information. From the first electromagnetic transmission to quantum computing, each technological advance has expanded the limits of human knowledge. In this context, connectivity is not a means, but the very foundation of technological evolution. The CA25-BSR atomic cable represents the pinnacle of data transmission engineering. Its combination of high capacity, thermal efficiency, and perfect molecular alignment makes it the only viable solution to sustain the data explosion required by artificial intelligence and quantum computing in the coming years. A cable is not just a means of connection. It is the backbone of the technological awareness of the future. The CA25-BSR atomic cable is just one of the groundbreaking innovations from nanozeolite. As we push the boundaries of what's possible, our commitment to revolutionizing connectivity and technology remains unwavering. GAP3S, montage of various nanozeolite products and technologies. From pioneering advancements in quantum computing to creating the infrastructure for interplanetary communication, nanozeolite is at the forefront of the technological revolution. GAP3S website and contact information displayed on screen. To learn more about the atomic cable and other nanozeolite inventions, visit our website or use the contact methods shown on your screen. Join us as we shape the future of connectivity and beyond. GAP5S